All right, so let's talk about solving equations with a couple of different special scenarios that I want to make sure that I explain to you. Okay, so let's take a look at this equation here. 2x plus 5 equals 15. Fairly typical two-step equation. We've done a lot of them like this. Okay, so we know that we would subtract 5 first from both sides. And so we would get 2x equals 10. We would divide both sides by 2. We would get x equals 5. We would plug 5 back in, so 2 times 5 is 10, plus 5 is 15, which is correct. Okay. Now, what I want you to do, though, is think about why is it that we chose to subtract first? Well, you might tell me, oh, it's reverse order of operations. You would be correct. So you might be thinking of good old PEMDAS. Usually you do parentheses, exponents, multiplication and division, addition and subtraction. And so going the opposite way would be addition and subtraction, multiplication, division, and then exponents and parentheses. Okay, now that's correct, but I also want you to think of it this way. When you said you did reverse order of operations, what you really meant was the way that you would normally evaluate this side of the equation, you did the opposite of. Okay, so if you knew what x was, you would have done multiplication first, and then you would have added 5. And so since you're doing reverse order of operations, that's why you subtracted 5 first and then divided by the 2. Okay, so you did do reverse order of operations. You did the reverse of the way that you would have evaluated that side of the equation. It's an important distinction because sometimes we run into fun little situations like this. Okay, so x minus 3, all of that divided by 4 equals 6. Now, if you say reverse order of operations and you're thinking, oh, I'm just going to run backwards up PEMDAS, that might not work out so well because that would have you adding 3 to both sides first, which would give you x over 4 equals 9. And then you would multiply both sides by 4, which would give you x equals 36. And if I plug 36 back in, 36 minus 3 is 33. 33 divided by 4 is not 6. So what's going on here? Well, think about how you would evaluate this side of the equation if you knew what x was. If I knew what x was, I would actually subtract 3 first because the top of the fraction acts as a grouping symbol. So it's like doing parentheses. And then once I knew what that was, I would divide by 4 because then next after grouping symbols is division. Oh, so when I think of it that way, that first I would subtract 3 and then I would divide by 4. Well, reverse order of operations would tell you then, start with what you did last. Since you divided by 4 last, that means that to undo this equation, we need to multiply by 4 first. So you multiply both sides by 4. Dividing by 4 and multiplying by 4 are inverse operations. That will give you 1 basically, which anything divided by 1 is itself. So this will leave you with x minus 3 equals 24. I'm going to pause here real quick before I go on to the next step and make sure that that made sense. Okay, so when I multiplied by 4 and divided by 4, those were the inverse operations. I do not need to distribute 4 throughout the top of that fraction because these are the two things that I am undoing. Okay, all right, and so then I have x minus 3 plus equals 24, so now I'll add 3 to both sides. Now I get x equals 27. Let's see if it works. So if I plug 27 back in, 27 minus 3 is 24. 24 divided by 4 is 6. Hey, it works. Okay, so just remember as you solve equations, yes, reverse order of operations, but reverse order of operations as you would have evaluated that side of the equation if you knew the unknown. All right, let me know if you have any questions on your practice.